Thank you for coming today. My name is Lloyd Adkins. I represent Group 1, Team United States of America, and the federal government. And during this briefing, we will be talking about the cyber operation and risk management. The agenda for today, we are going to go over software assurance, software development lifecycle, supply chain risk, software development lifecycle risks and vulnerabilities, recommended software option for the organization, supply chain costs, recommendation, contract language recommendations, and then at the end, we will take questions. So what is software assurance? Well, software assurance is the level of confidence that the organization has in software. They have to make sure that these softwares are free of vulnerabilities, whether they are intentional or unintentional, and that the software also performs as expected. This is important because of the processes, the procedure, and the production that the company needs to do and to be able to perform. We also have to make sure that the software intensive systems are secured at all times. And we can do this with software assurance because it provides us quality, reliability, and safety. So there are several steps to software assurance needs. The first one is to evaluate current state in software security. Basically, we have to develop future plans. We have to identify possible risks and threats of the entire software and ensure that they are fixed before they are deployed to everyone. Review and perfect the code. This has to be done before deployment of the code. We have to complete all testing by verifying that there are no vulnerabilities before it is sent out. A gate must be developed to prevent vulnerabilities from entering the product at all. 6, measure success and security plans and develop improvement strategies. So we're not just here to measure the success of the security plans, but we need to also develop improvement strategies in order to continue being better. And 7, and lastly, we need to educate all parties involved of the security plans so when they are implemented, they can be implemented to the fullest extent. Software development lifecycle. What is it? Well, a software development lifecycle is a framework that defines the steps involved in the development of software, and it breaks it down into phases. What is involved are these phases. And the phases are planning, requirements, design and prototyping, software development, testing, deployment, and maintenance. The SDLC, or Software Development Lifecycle, defines a methodology for improving the quality of the software. In order to do this, we have to break down these phases. Software development life cycles continued. So these are the phases that the software development life cycle are using, phases 1 through 7. Phase 1 is planning. The planning phase is where key decisions are made regarding the overall purpose of the software, how to achieve it, and how to address issues as they surface. Phase 2 is the systems analysis. The systems analysis phase is where the project requirements are taken into consideration in order to analyze and create documentation based on the requirements that have previously been defined in the planning phase. Phase 3, system design. The design phase is another critical step in the SDLC. This is the phase where the software begins to take shape and come into a pictorial representation of the desired outcome. Phase 4, development. The development phase of the SDLC is where the functional requirements are transferred to a specific computer to register as a code. Phase 5, testing. Once the code is finalized from the previous phase, the software is then passed on to the testing team. The testing team begins testing the software by performing unit testing, integration testing, database testing, and functional testing. Phase 6, implementation. The implementation phase is also known as the deployment phase of the SDLC. This phase will define all the necessary requirements of the software in order to create specific system requirements for the hardware that the software will be utilizing. And finally, phase 7, the maintenance phase. The final phase of the SDLC is the maintenance phase. This is essentially an extra step in the implementation phase, seeing as during the implementation phase, at the end of it, the customer has been presented with the software. However, in case anything may happen with the software, the 7th phase of maintenance is there so that we may continue to help our customers as we go forward. Supply chain risk. As it comes with supply chain risk, it can come in many different forms. We have to mitigate this risk by vetting all vendors, manage insider threats, manage vulnerabilities, and we have to continue to educate the employees. On these tables up top, you can see counterfeit is an unauthorized modification, diversion, or unauthorized substitution of the general part. Critical component is a component which is or contains ICT, including hardware, software, and firmware, whether custom, commercial, or otherwise developed, and which delivers or protects mission-critical functionality. Interception and modification. These are components or software. This is where components or software is intercepted during transit and purposely modified to introduce vulnerabilities to the software. Insider threats. This could come from anybody, disgruntled employee, technology vendors, material suppliers, whether it's food or office or others, shared public infrastructure, open Wi-Fi, and other public services. The software development lifecycle risk and vulnerabilities. There are many different software development methodologies: waterfall model, prototype model, agile software development, rapid application development, dynamic systems development, spiral model, extreme programming, feature-driven development, joint application development, lean development, and rational unified process. There are many pros and cons to each, and we do have concerns with each one as it comes to software assurance. However, the agile software development pros are easy testing and maintenance, able to respond to changing requirements of clients, allows for creative revision and improvements, direct communication with clients, and no room for guesswork. A con is no setup project deadline. Estimating required resources is challenging, and focus on software rather than documentation. The lack of documentation does limit the ability for modification and testing by anyone besides the actual development experts on that project. The spiral model, suitable for large and complex projects. Possible risk and significantly reduced with risk analysis. Additional functionality can be added later. Appropriate for high-risk projects. Cons of this are development is costly. Only suitable for high-risk projects. Development may be inconclusive and continue indefinitely. Dependent on risk analysis, flaws in risk analysis can weaken this project. Some software assurance concerns that we have about it are the ongoing nature of development process that can make the project susceptible to vulnerabilities and threats the longer it continues. And that is just to name a few of the risks and vulnerabilities that are within the software development lifecycle. Recommendation software options for the organization. As it pertains to the federal government, we have narrowed it down to the 4 models: agile software development, spiral model, dynamic system development, feature-driven development. And we believe, after going through the pros and cons and the system assurance concerns that we may have on each of these, that the agile method would be the best method to implement into the system. The cost of the projects tend to average $10 to $20 million. Those are very big projects. However, the results outweigh the cost. So the supply chain cost for the ICT supply chain risk management implementations, $236,000, with vendors being SAP, Oracle, JDAA. For security and patch management, $184,000. So that's going to be Patch Manager, KCVSA, or SolarWinds. Then we have the implementation of cyber risk management software. That's going to be $401,000. And the vendors we will use for that is Logic Manager and KDM Analytics. And now we're moving on to contract language recommendations. In order to go over the recommendations, we have to understand what contract language is. And the language within a contract is basically terminology to establish a connection between 2 or more parties. Why is this important? This is very important because ambiguous languages could lead to loopholes and lead to contentious litigation on either side. Tips we can use is to avoid ambiguous language. We have to be clear and concise on everything that is written down. We must clearly define acceptance criteria. Have to make it to where everybody understands what is expected from one another. Must remain specific on calendar days. You cannot say 30 days out. You must say on September 22nd, as an example. And you have to specify the currency that is being exchanged between the parties. If it's a global system, it could be in any denomination. So we have to make sure that the currency is also specified within the document. Now, our recommendations for software assurance. Incorporation of software development projects. We must define our business goals, prioritize funds, and manage risk to the best of our abilities. Enable resilient technology. We have to make sure that the technology that we have in place will be strong enough to keep out all the malware and any kind of vulnerabilities that may be heading our way. Sustain secure environment and to achieve business goals through the technologies that we use. Are there any questions?